こんばんは。今日、忙しい時に来ていただいて、どうもありがとうございました。Good evening. Thank you for taking the time to attend today's seminar, The Noto Earthquake, Implications for Natural Hazards Preparation in Washington State. The event has been funded by a generous grant from the Consulate-General of Japan in Seattle and coordinated by the Japan-America Society of the State of Washington. My name is David Yamaguchi. I'm the executive director of the society and will be the MC for today. It's appropriate that we begin today's seminar with a mokuto, which is a silent prayer for the victims of the Noto earthquake. And so we'll give it a minute or so. Thank you. Next, we begin with brief opening remarks from Junichi Sumi, who's Deputy Consul at the Consul-General of Japan in Seattle. Sumi-san is the #2 representative of the Japanese government locally, and so if you need some special non-routine service from the Japanese government, the chances are good that your request will land on Sumi-san's desk. Before arriving in Seattle in March 2023, among other assignments, Sumi-san has been one of Japan's Middle East experts. He served in its Ministry of Foreign Affairs in Iran, Afghanistan, and Iraq. In addition to Japanese and English, Sumi-san speaks Farsi, which he learned in a master's degree program at the University of London. Sumi-san, onegaishimasu.
Okay, good evening, ladies and gentlemen. Thank you very much for the introduction. So brief remarks. I have a lot of things to talk about. Half an hour is okay. So when it's come to the earthquake, I have a lot of stories. I haven't chosen one yet about the one in Iran when I served like over 20 years ago, or the one and the recent one in Noto. When it's come to the Noto, hopefully the Funaki-san is coming. He is also newly established Ishikawa Kenjinkai's president. Hopefully he will join us soon. And also it's hybrid, right? Hoping that one of the organizer of Ishikawa Prefecture Kenjinkai's organizer, Luke Ayumi-san, she's now in Noto in Japan, and hopefully she's watching us with her friends. And they are affected by the Noto earthquake New Year Day this year. And because that was a kind of initiative to start the Kenjinkai, those prefecture groups. Those are related to Ishikawa recently, and I'm #1 Kenjinkai member, even though I never been to Ishikawa yet. And so I wanted to talk about the story that about earthquake of almost 13 years ago, or over 13 years ago. in Tohoku, where the big scale, I mean, one of the biggest scale earthquake hit, and the tsunami, and also nuclear disaster. I was serving in Iraq and then taking a leave. I took a leave and I was in Tokyo, and I happened to be in the Ministry of Foreign Affairs. I didn't need it to go to the office, but those couple weeks break, I just happened to be at the office in Ministry of Foreign Affairs, 6th floor, and then the earthquake happened. It was long and huge. We started feeling, okay, it's an earthquake, you know, Japanese people get used to it. Okay, fine. Long and big. We had to, you know, hold the TV and all the shelves. And then we thought that this is huge. And this must be in the center of Tokyo or somewhere nearby, because it was the biggest one that I felt after 45 or 40 years. And then we saw the news, and they said that the center of the earthquake is far away from Tokyo. It's in Tohoku. So we all immediately understand that this is not normal. Yeah, so we started, okay, everybody, we cannot go home tonight. We have to stay. And first we have to eat and be ready, and to check all the colleagues' safety, and also all the embassies, staff, foreign diplomats' safety. And then at the time, I had a newly born daughter, and I had to run to find the water to make her milk. You know, I couldn't believe that, you know, that was kind of first week, it was a panic, and this supply chain stopped, or maybe people had some thought that maybe we need to get as many bottles of water as possible, or, you know, pasta or rice. So all the shops had, even in Tokyo, because the earthquake hit in Tohoku, but right after the earthquake, there was a kind of panic even in Tokyo. So there are a lot of things that, you know, we learned lesson, and compared to Washington States, sadly we have these experiences of a big earthquake. One is also in Kumamoto some years ago, and hopefully those lessons learned. I have little idea what happened in Noto Peninsula this year, other than the news. So hopefully I can hear more about the lessons learned from the Noto earthquake, and hopefully this will help the preparedness of Washington States. And I'm very happy that we have a representative from the Washington States, and he will have a few words, but that's very important for us, because we have Japanese government has a MOU, Memorandum of Understanding between the Washington States and the Japanese government. And one of the pillar is disaster management and risk reduction. So I hope that this event has some insight and help the preparedness and strengthen the tie between Japan and the United States. Thank you very much.
Next, it is my pleasure to introduce Robert Ezell, Director of the Emergency Management Division of the Washington Military Department. EMD is responsible for leading and coordinating mitigation, preparation, response, and recovery activities to minimize the negative impacts of disasters and emergencies on the people, property, environment, and economy of Washington State. During Ezell's tenure, EMD has successfully supported the response and recovery from several major disasters, including the Oso landslide, the record-setting fire seasons of 2014 and 2015, and a host of other devastating weather events. Robert Ezell.
Good evening, everyone. And good evening, Deputy Consul General Sumi, and other distinguished guests. It's an honor to be invited to speak at such an important event. I'd like to thank the Consulate-General of Japan in Seattle and the Japan-American Society of the State of Washington for bringing together such a distinguished panel of expert speakers to address the implications of the Noto earthquake for natural hazards preparation in Washington State. Washington State and Japan face similar geologic hazard profiles. As the person responsible for coordinating preparedness activities across our state, I follow closely what's happening in Japan because what we see over there will happen here at some point, and we have a lot to learn. As the Deputy Consul General mentioned, we have agreements between Japan and Washington State, and we truly value those agreements because it gives us opportunities for partnership, for learning, for the exchange of ideas and best practices. And we really do put into practice a lot of what we learn from our partners in Japan. Earthquakes and tsunamis are among the most destructive natural disasters that can strike our nations. My heart goes out to the people of Japan for the tragic loss of life experienced at the beginning of this year. And it's a stark reminder of the important work that we do to prepare our people and communities and to do everything within our power to minimize the impact of earthquakes to our communities and our built infrastructure. In our state, we've undertaken a number of key initiatives, and they will sound very, very similar to our partners in Japan. What we're trying to do is buy down the earthquake risk. And so we're running many earthquake and tsunami exercises. We're doing a lot of catastrophic planning. We do the Great Shakeout exercise every year to try and get the attention of people, what they need to do in an earthquake, how they need to prepare. What I'm really excited about is that the legislature gave us funding to create a resilience team in EMD, and we're going to be using that team to build a statewide resilience strategy going forward. Also, they gave us funding to do a functional recovery study to look at how we can make certain buildings and structures stronger so that they will withstand that catastrophic earthquake and then be usable afterwards. I'm just excited to hear the words of wisdom that our panel will be sharing with us this evening. They're recognized experts in the field, and I'll be honest, I didn't know that much about Cascadia until I read Brian's work and Sandi's work, and so thank you for the pioneering things that you've done in our state. And they're going to give us much to think about, but beyond thinking, hopefully what they give us will spur us into action. Thank you.
Okay, cross your fingers. Next up, we have Naoto Hirata, who's recently retired from the Earthquake Research Institute at the University of Tokyo. His abbreviated biography, along with those of all remaining speakers, is in the printed program. To it, I would add that this soon after the January 1 Noto earthquake, we are very lucky to have any geologists speaking to us from Japan at all. When the Japan-American Society first began emailing the Earthquake Research Institute, the first responses that we got from their director were, all of our people are too busy. Hirata sensei, onegai shimasu.
Okay, thank you very much for inviting me, and it's very my honor to be here. Good afternoon, good evening, everybody. But it's in the morning in Tokyo, Japan. Ohayo gozaimasu. Okay, I'm gonna share my slide. Okay, I would like to review of the Noto earthquake. The official name by Japan Meteorological Agency, JMA, 令和6年能登半島地震. The name of Noto Hanto, Hanto means peninsula. So this is actually an earthquake occurred in the peninsula. Okay, where is Noto Peninsula located? Okay. Noto Peninsula is located about the middle of Japanese island, and the Wajima City and Suzu City, Noto Town, Anamizu Town are located in the northern part of this peninsula. Wajima is one of the famous place for Japanese traditional lacquerware, what we say Wajima nuri, and some of you know this lacquerwares. And in this area, the population is about 60,000, and the area of this the land is about 1,000 square kilometers. That means we have about 1/10 population as compared to the Seattle, and in the land with 10 times larger area. So that means this area is basically countryside area. Okay. The tectonic situation of area is, I'm gonna explain this area. Okay, we have a Pacific Ocean here, and on the western side, Japan is located, and Seattle, Washington, state of Washington is located in the eastern side of the Pacific Ocean. And beneath this ocean, we have what we call Pacific Plate. This is the tectonic, this is the largest tectonic plate on the Earth. Okay, and on the western side of the Pacific Plate, the Pacific Plate is subducting beneath from the Japan Trench westward, and basically the Japanese islands are with the compression east-westward, and this area is under the compressional schemes. And the eastern side of the Pacific Plate, there is a Pan de Fuca plate, and the Pan de Fuca plate is subducting eastward beneath the North American plate. Okay, this is the tectonic current tectonic situation. But in ancient age, say about 20 million ago, the Japanese islands are a part of Asian continent. And about 15 million ago, Japan Sea has been opened, and Japanese islands goes basically eastward. So those area has a very large extensional tectonic scheme, but at the present we have compression schemes. So this makes the tectonics very complicated. We have a very ancient extensional regime, and the current status is compression. Okay, this is a very short summary of the tectonic situation in Japanese island. Okay, this is the summary of the 2024 Noto Hanto earthquake. The most important aspect of this earthquake is very large earthquake. Okay, the magnitude of this event is 7.6 in what we call Richter scale. So this is compared to the 1906 San Francisco earthquake, that the magnitude is 7.9. Okay, this is smaller than 1906 San Francisco earthquake, but this is larger than 1995 Kobe earthquake. Okay, another important thing is the seismic intensity of this earthquake records 7 in Japan Meteorological Agency scale. Okay, what is the seismic intensity? The seismic intensity is a degree of strong motion, but unfortunately, each country has different seismic intensity scale. We use Japan JMA scale. The seismic intensity is from 0 to 7. We have 5 minus 5 plus and also 6 minus 6 plus. So we have totally 10 scales in this Japanese intensity scale. So we have intensity 7 in Noto Hanto earthquake. So that is the maximum intensity by definition. Okay, if we have intensity 6 in JMS scale, all the wooden house may collapse. And if we have a 6 upper or 7 earthquake, it's very likely to be collapsed. So this is a very, very strong intensity generated by this earthquake. Okay, another point is a very wide area has been affected by this earthquake. I show the map. This map shows the area of very strong intensity. Approximately 300 kilometer wide area has been affected by this earthquake from Noto Peninsula to Sado Island. So this is from Ishikawa Prefecture, Toyama Prefecture, and also the Niigata Prefecture has been experienced by this very strong earthquake. And also this earthquake generated a very high tsunami. So this table showed the observed tsunami height at, say, Toyama port. We have 0.8 meters. So that is a 80 centimeter tsunami height. And those tsunami are observed a very wide range of Japanese coast, and some are in Korea Peninsula and also the Asian continent. Okay, 0.8 meter looks not very high. However, we have, okay, this is the example of a waveform of the tsunami, but we have evidence of a very high tsunami trace in this is an example of the western side of this peninsula. And Akasaki Fishery Port, we have 4.2 meter tsunami height. Because the earthquake happened very close to peninsula coastline, the tsunami hit the coastline very quickly, say a few minutes. Within a few minutes, a tsunami hit the coast. Okay. And what we call the focal mechanism of this earthquake is reverse faulting with compression in northwest and southeast directions, basically north-south direction. Okay, what is the reverse faulting? Okay, reverse faulting means the upper part of the fault plane move up against the lower plane. So this is a reverse faulting movement. So basically, southeastern part of peninsula went up about maximum 9 meters at depth. And also we have a slightly right lateral sweep along the fault, south fault, and the Noto Peninsula moves westwards. Those analyses was done by seismic waveform data, and also we have satellite data which shows a very large uplift of peninsula and also westward movement of the peninsula. Okay, this is one of the satellite data which shows the very large uplift, 4 meters, and also westward movement here. Okay, 4 meter uplift is very large movement. Imagine that this is the larger than the height of the houses from the ground floor and the second stories. So this is a 4 meter uplift, is the very high movement. Okay, so we have many area make the area to be land. Okay, this is the photo taken by the airplane, and the left side is the before 2024 earthquake, and right side is the after the earthquake. Okay, you can show the land area appear. It used to be a sea area. Okay, this is a photo taken by an airplane and also a photo on the ground. The previous sea level is about here, and approximately 4 meter uplift can be observed here. This was the port that we this is actually the fishery port. So, okay, this is the before the earthquake. There are many waters. Of course, there are many waters because this is the fishery port. But now all the area become land. So this is a very serious problem for the fishery people. The impact of this earthquake is very large. More than 240 people were killed by the earthquake, and about 10,000 buildings are completely or half destroyed. So this is about a half of the houses and buildings in this area, Ishikawa area. So even the Ishikawa area, we have many damages, but also in Niigata, Toyama area has a very serious damages. So Niigata area is, say, 300 or 400 meters from the epicenter of this earthquake. But actually, the source area of this earthquake is from the western side of the peninsula to the middle of the Sado Island and Ishikawa Noto Peninsula. So even the epicenter of that is the initiation of the rupture is located in here, Suzu City, but the total area of the source area is somehow 150 kilometers long, very large area. Okay, so we have about more than 200 people fatality because the very large area affected by a very strong ground motion. I went there middle March, 2.5 months after the earthquake happened. So many houses are still something like this. So it's at the totally collapsed and half collapsed. This is the situation in the Suzu City and the northern part of the Noto Peninsula. Okay, this video shows the many disaster debris is still there. It may take a long time to remove and rebuild remove the disaster debris and rebuild houses and buildings. And we have temporary houses in there, and the plan is approximately 9,000 such kind of temporary house, but still only 1,000 houses are actually built. Okay, we have a very prominent storm activities since 2020, December 2020. And also we have magnitude 6.9 big earthquake in 2007. That means this area has many earthquakes, and I believe the people feel strong ground motion before this New Year's very big earthquake. However, even they feel earthquake, the preparation for the earthquake is not a very good situation. Okay, such earthquake are not only the case in Noto Peninsula, but we have 1964 Niigata earthquake, magnitude 7.5, and also 1983 7.7 earthquake, and also 1993 7.8 earthquake happened. So along the Japan Sea coastline, we have a lot of earthquake, and people should prepare for those earthquake. However, my understanding is the preparedness is not very good. Okay. The summary of my talk is the seismic event is a very large inland coastal earthquake. So we have a very strong ground motion in wide area, and also the active aftershock followed the main event is still ongoing. Approximately 9,000 houses are completely destroyed, and the fatality is more than 240. Okay, the tsunami impact also very large, and the both strong ground motion and tsunamis compounded the disaster. The rapid arrival of the tsunami was due to the nearby coastal earthquake. So the geological consequences are very significant reverse faulting, and which cause the sea area to be land along the coast. And we have a new marine terrace in Noto Peninsula. Okay, that's all. Thank you very much for your attention.
At this point, it is easy for all of us to wonder how the Noto earthquake and tsunami on the other side of the world relate to us. To add clarity here, Brian Atwater will read our rocks and mud for us. To summarize Atwater's career, since the late 1980s, he has been the #1 person leading the charge to prove that huge earthquakes have happened in the Pacific Northwest in the recent geologic past. As the past is the key to the future, our records suggest that we must continue to prepare for the next one. Brian.
David-sama, omaneki itadaite arigatou gozaimashita. Thank you, David, for inviting me. Japan teaches us so much, and we're when it comes to understanding of earthquake hazards here, with our subduction zone, the Cascadia subduction zone, it's Japanese written records from 1700 that gave us an exact date and an approximate time for our most recent great earthquake. But with regards to Noto Hanto, could we kill the stage lights, because the slides are very hard to see, I think. Anyways, with regards to Noto Hanto earthquake, it serves as a reminder that we have a history here also of big earthquakes on faults that are very close to us. In fact, this one right underneath our feet. And so I'm here to recount a little bit of the detective work that was done in the early 1990s to to learn about this history. The most recent update, oh, that's wonderful. The slides will be really visible. Go for it. Okay. In any case, the very last point that Hirata Sensei mentioned was that a new marine terrace had been created. And here you have an old marine terrace that many of you have seen. Oh, let's see. That's a little better, thank you. And you see it from the ferry. When you go to Bainbridge Island or to Bremerton, there's a golf course on it. And the present day marine terrace is being cut by the waves in the foreground, right? And then the bench that the golf course is on it used to be the floor of Puget Sound until almost exactly 1,100 years ago. And so it's a story of this particular earthquake that I'm going to tell you just a little bit about the evidence for that. Let's see. I need to advance here. Okay, so these are hand-drawn cartoons, very nice style back before PowerPoint. And the tectonics here is unsophisticated. These are meant to be cartoons, but the basic idea is that, as with the Noto Hanto earthquake, there was uplift along one side of a fault. And that uplift also moved the sea surface, Puget Sound surface up in this case, and gave rise to a tsunami. The effects in addition for this earthquake were landslides, and landslides into Lake Washington have brought forests, old growth forests, to the floor of Lake Washington, where the trees posed a navigational hazard upon completion of the locks at Ballard, and the tops were taken off by the Corps of Engineers. But anyways, the main strand of this big fault zone runs east-west across Puget Sound, probably going all the way over to Hood Canal. And in simple cartoon view, it's running pretty much under the upper tip of it is underneath our feet. So we're going to look at just a bit of the evidence, not just the uplift. We saw the evidence for uplift down at Restoration Point, but we're going to go to West Point. And all of us rely on West Point here in Seattle as the place where wastewater is treated. And there's a close connection between wastewater treatment and geological detective work. And so we'll look at that. Okay, so that's why we're starting with the sewage treatment plant here. And how many of us go out to Discovery Park for walks? Okay, so everybody, you've been out to the lighthouse and you've noticed, and those of you who were out there before the early 90s would know that the sewage treatment plant used to be limited to the western part, but now you've got quite a bit more out there. And that's from an upgrade that was done back around 1991, 92. But to roll the clock way back to 1867, a beautiful map that I've just colored it, but these were remarkable surveys done by a co-survey topographer named James Lawson. And you can see the sands, in brown is the high ground of a sand spit that rimmed the peninsula. And then inside of it was a salt marsh that I've shaded green. And there's a little black line with a white halo that represents the excavation you'll see pictures of. On the cartoon on the right gives you a sense of the environments, the forest on the upland, the tidal marsh, the beach berm, and then out onto the tidal flat. And essentially what happened during that earthquake 1,100 years ago is that the land here dropped, and what had been tidal marsh became tidal flat. And a tsunami came in across that downdrop tidal marsh, and it deposited things, you'll see. But anyways, West Point's been a place for a destination for wastewater for a long time in Seattle. And some of you know this history of creeping socialism in Seattle. And the wonderful story about Edmondson, you know, is that he was a zoologist who figured out that Lake Washington was eutrophying. And an opponent to the formation of Metro said, well, what does Edmondson know about lakes? He's a zoologist, and that's a person who studies animals in zoos. So, but he really, his work was fundamental. Science in the 50s was fundamental to the creation of Metro and the building of a serious sewage treatment plant out there at Discovery Park. What's now Discovery Park then was just Fort Lawton, right? And so here it is under construction, the original plant in the 60s. And then the EPA, or maybe it was the State Ecology Department, I can't remember which, dealing with the Clean Water Act signed under Richard Nixon, said, you know, Metro, your solution to pollution is not dilution. In Puget Sound, you need to do more treatment. There are too many nutrients getting into Puget Sound. And so they did a big upgrade starting in 1991. All right, so I got to start to work out there. I learned, this was at a time when that marine terrace at Restoration Point and some other evidence for uplift, that was really getting people's attention in the geological community. And we wondered, did that terrace really rise during a single earthquake all at once, or did it slowly rise? And so we thought, okay, if it came up so suddenly, then it should have displaced the water at Puget Sound and made a tsunami, right? So this big excavation that they did out at West Point, they dug down through thousands of years worth of Puget Sound history, and it was for laying this two-level system where they had a 9-foot diameter main effluent pipe, and on top of that, they put a gallery of other plumbing that flooded during there was a disaster out at West Point that recently, and that was from that. And they worked slowly along there with lowering this into rebar cradle, and they had big dewatering pumps because the water at Puget Sound would perk through the gravel. But that's really the size of the backhoe shovel that they were using. They've done a beautiful job here of, I've labeled it says 900 to 930 CE, and the dotted line goes down to a gray line. It's a gray layer. It goes underneath the hand of the woman in blue. And that's the sand sheet that marks this tsunami from this earthquake. And then above it is tide flat deposits from where the land had dropped. And here's what it looked like up close. There were soils. There were both gray and muddy and darker and peaty, but there were soils of tidal marshes sitting underneath the sand sheet. And then the sand layer was coarsest at the bottom, and it graded up into finer stuff. And then it had plant trash. And it had been laid down on the salt marsh, and the stems of the salt marsh plants were still sticking up vertically through it. And the tide flat mud that accumulated on top that locked out all the oxygen they are just all perfectly preserved. And so the simple story, there were sedges there, and the land drops, the tsunami comes in, lays down the sand, and then on top, tidal flat mud surrounds the stems of the plants before they have time to decompose. Okay, so here's an ethical quandary for you. And you're the geologist out there, and I remember this date very well, the 28th of February, 1992. And your contact out at Metro has said, hey, Brian, they've just done some additional new digging, so you better come out and look at the excavation. And you get there and you see this big wedge of purple stuff. And it's mostly mussel shell, but there are mammal bones and charcoal and fire-cracked rock. And you've been talking at this point with some of the iron workers, the two people who are over there at the left, one of them female. And they've asked you, they've had that usual confusion between geologists and archaeologists. And they say, well, you know, we've been on jobs where if you find a bone, you're not supposed to tell anybody, right? And so this is obviously a big shellman. And by this point, I've been working out there enough. I knew it was, and already gotten radiocarbon ages back. I knew it was at least 2,500 years old. And so do you call Metro and let them know that they've dug into an are you going to put these people out of work? Well, it turned out the person running this had a 40-ring circus, and he just moved his people elsewhere, and he got done ahead of schedule and under budget. So it didn't kill it, but they brought in wedding tents and porta potties for the archaeologists, and he gave them a drop dead date of July or something. It worked out. But anyways, you see the beautiful stratigraphy all the way up to what had been the land surface before they started the sewage treatment plant and poured stuff in there. Okay, so my job as a geologist, sort of surveying this along as they steadily did their excavations. So this is a couple of months worth of excavation, logged piecemeal. And the sand sheet we've been looking at is labeled there through the middle, and the midden is down there in purple, and there are debris flow deposits coming off the hillside. What I've labeled sewer is the sand that they pumped in to build the sewage treatment plant. But it's very beautiful evidence for a sudden down drop and a sand sheet laid down on the down drop surface. Tide flat mud builds rapidly up, and then a marsh takes over, and that's the last 1,000 years. Okay, but the archaeologists really helped me with one thing, is they slowed the whole damn thing down. And I had time to log excavation that I hadn't been paying attention to. And one of the things that showed up was this great big Douglas fir log. And you can see the bark preserved off it on the right-hand side, and the blonde wood where the thing is the piece I cut has fallen over. And it had bark on all the way around except at the very tippy top where it had been oxidized a bit. And underneath this thing were the flattened stems of those bulrushes and a little bit of sand. So, and the limbs of this tree were still flexible, and they had bark on them. They've been jammed into the mud underneath. So this is some log, probably a tree that came down in a landslide, got picked up by the tsunami, and dumped onto the marsh here and impaled its limbs into the ground. Then the tide flat mud builds up around it. And so this became a pretty helpful piece of a story where this a coworker of David's, a tree ring scientist here, Gordon Jacoby, matched the tree ring patterns of that, we called it the sewer log, with trees from the floor of Lake Washington that had gone down to the bottom of Lake Washington on slides. And he figured out that these trees had died during the same non-growing season. And that work has been updated now, so the tree ring scientists tell us that those trees died during the dormant season between 923 and 924 in the Common Era calendar. So almost exactly 1,100 years ago. All right, so that 923 through 924 story is in there. Sandi wrote the best account of that. It's really wonderful. Look up her article in the Seattle Times about it. But so we've been to West Point. We've looked at evidence for tsunami and for subsidence as part of an earthquake here that's 1,100 years ago. The faults involved, in addition to the Seattle fault running east-west, according to the tree ring people recently, it's the Saddle Mountain East Fault along the west side of Hood Canal. And the bigger picture, of course, is that we have these multiple sources of earthquakes here, and the Seattle fault is just one of them. Thank you.
To summarize the career of our next speaker, most Washington people would not know anything about Brian Atwater's work if he had not been followed around across the years and decades by a dogged Seattle Times science writer. That journalist is Sandi Doughton, who we're especially lucky to have here today, as I think she retires at the end of this month. Doughton has also been on the ground in northern Japan following its 2011 great earthquake. The main thing about Doughton is I think that she's really smart and she doesn't mince words. She calls a spade when she sees one. Sandi, tell us what you think.
Well, I don't know about being smart. That was kind of you, Dave. Thank you so much for inviting me here. You know, I'm not a scientist, I'm not a seismologist, and I'm not an emergency management expert. My perspective is that of an outside observer, and it comes from reporting about earthquake science and preparedness in Washington for several decades now. And I have to say, this headline kind of sums up what myself and my colleague, Daniel Gilbert, found a few years ago when we took a deep dive into the level of preparedness at the state level here. And earthquake preparedness has never been a high political priority in the state of Washington. We've had expert panel after expert panel study the risk and come up with a remarkably consistent set of recommendations for upgrading our vulnerable infrastructure, which is what we really need to do here. And so far, not too much has come of it. I think things are changing a little bit now, and I'm glad to hear that. And this is in no way a criticism of our excellent State Emergency Management Division of Robert and his people. They do a great job, but they're affected by this as well, because for as long as I covered them, they were chronically underfunded and understaffed and trying to do, a gigantic job. So I was really happy to hear you say that you're getting some money now, some funding for functional recovery and resilience work. So that's fabulous. I'm really glad to hear that. I think our main problem here is frankly that we just don't get earthquakes often enough. In Japan, it's different. Earthquakes are happening all the time, but it's been a long time since we've had an earthquake like the one Brian just spoke about, or a Cascadia subduction zone earthquake. In fact, our last, destructive earthquake of any type was almost 25 years ago. So it's very easy for politicians here to just kick the can down the road, and it hasn't come back to bite them yet because it hasn't happened on their watch. So, but we are, things are happening. There's a lot of progress going on here, and it's really thanks to people in state agencies, our wonderful bureaucrats, the people who work with Robert, his team, people in our state Department of Natural Resources, the Washington State Department of Transportation, people, agencies that have experts on staff who know the risk and are, chipping away at it as best they can, a little bit at a time. One example is here in the city of Seattle, where we have over 1,000 unreinforced masonry buildings. So these are old brick buildings. This is one that was damaged in the Nisqually earthquake in 2001. And these are horrible places to be in an earthquake. They collapse and they kill people. And that's been known for years. The city has been trying for almost 30 years to require retrofits on these buildings. And they just, the owners will object, the city backs off, so nothing has been done. But now they're taking another run at it. I have to admire their persistence. And what they've done is come up with a kind of a standard template, a standard type of retrofit that can be done and is just enough to prevent the buildings from collapsing and killing people, but also give the building owners some kind of assurance that they have met the requirements. Right now, it's still a voluntary program, but the city folks tell me they're going to try to make it mandatory, and if they can do that, that would be great. Another hazard that we've barely scratched the surface of here in Washington are old concrete buildings. They're called non-ductile because they don't have enough rebar, reinforcement in them. So in earthquakes, they can pancake. And they're generally big buildings, and so a lot of people die in these kinds of buildings around the world. This was one of these old concrete buildings that collapsed in an earthquake in New Zealand several years ago. We don't even have any idea how many of these we have in the state of Washington yet. Places like Los Angeles and other parts of California have inventoried these buildings, and they're requiring that retrofits be phased in over time. Hopefully, maybe that will be part of your functional recovery work, Robert. I hope so. Our roads and bridges were mostly built before we really understood the nature of the earthquake risk here. This is a bridge over the Skagit River on I-5 that was knocked down by a truck several years ago. It's kind of analogous to what happened today in Baltimore. I'm sure a lot of you saw that. Not as bad, but it still cost millions of dollars and took months, I think, to repair this. And this is, FEMA says that thousands of bridges across the region could be damaged seriously or destroyed in a Cascadia subduction zone earthquake. This is just a map that shows that. So, this is an example of the type of problem we face here in Washington. It seems overwhelming. We have all these roads, we have all these bridges. It's an enormous cost to upgrade them. But what our State Department of Transportation has done is just basically incorporate that into their regular maintenance schedule. So they've identified about 900 bridges and overpasses that need seismic retrofits, and they've just been chipping away at it over the decades. And so far, I think they've done about, I'm going to skip a slide here. They've done about 400 of them. This is some work several years ago on the Aurora Bridge here in Seattle. WashDOT is also working on what they call lifeline routes. So this is a route north and south and east and west that would that they could quickly reopen after an earthquake, so you could get supplies and people in for the recovery. And so this is, you know, this is the way to do it. We don't know when the next earthquake is going to strike, but we're probably going to have several decades. And if, you know, if other agencies followed this lead and just, you know, improve things incrementally over time, we would be in a lot better position. Unfortunately, our utilities haven't really embraced this philosophy as far as I know. So we have a lot of particularly water and sewer systems here that are very, very vulnerable. This is a picture from also Christchurch, New Zealand, where people were lining up for water months after the big earthquake there. So we can expect a lot of disruptions to our utility systems. But honestly, the thing I worry most about are schools. When my colleague Daniel Gilbert and I looked at this several years ago, we found that almost a third of children in Washington State live in earthquake-prone areas and attend school in buildings that were constructed before the adoption of modern seismic codes. We also have quite a few schools that are in tsunami zones, some of them in low-lying areas where there's virtually no way to escape. This is one of them. This is an old picture from Ocosta Elementary School in Westport. And I love this story because this is a small community. It's a rural community. They have one of the lowest per capita incomes in the state, but they voted to tax themselves to build what is our state's first tsunami evacuation structure. So this is what it looks like now. It's basically a new gym at the elementary school, and it was designed to stand up to the earthquake and the tsunami and to be tall enough that it won't be overtopped by the water. And so almost 1,000 people can take shelter on this roof. Not only the students, but the people who live in the area. And as far as I know, they didn't get a penny from FEMA for this. And that's a big burden for small communities, small rural communities who just don't have the tax base, don't have the money. But recently FEMA has started providing some money for this kind of work. And this is our state's second tsunami evacuation structure. It was built just south of Westport by the Shoalwater Bay Tribe of Indians with some funding from FEMA. And the thing I love about this is that they could have put it like right in the center of the reservation, right? But they didn't. They put it out on this, outlying area so it could serve not only the people who live on the reservation, but also their neighbors. So that means, so now we have 2 tsunami evacuation structures in the state of Washington, which is a great start. I'm really, really pleased with that. But an analysis by Robert's shop, the Washington Emergency Management Division, recently estimated that we probably need between 55 and 85 of these along the coast to protect all of our vulnerable populations. And what about all these schools that aren't in tsunami zones, but are just not seismically sound buildings? Well, recently, our state legislature took what I think is, in the time that I've been covering this, is their most significant step ever. And that is they created the School Seismic Safety Program. Now, we're way behind California, Oregon, and British Columbia. They all did this a long time ago, and they're much further down the road, but it's a start. They started as a pilot program in 2020, and last year they got $100 million for the next 2 years to upgrade these dangerous school buildings. They've only completed, I think, about 3 retrofits so far, but they've started the process at another dozen or so schools. So if this is something that our state legislature will continue funding, then, 20, 30, 40 years from now, we'll be in much better shape. And maybe we won't have any children like this, children at risk. These kids attend a preschool in Aberdeen that has a 90% chance of collapse in an earthquake and is also in a tsunami zone. So we don't want that. Thank you.
Okay, our final speaker is Sophia Lopez from the City of Seattle Office of Emergency Management. Probably her perspective matters the most to everyone in the room. If you are in the room today, I would guess that you are likely a Seattle person who will be in Seattle when the expected big one hits. Sophia.
Thank you very much for having me today. It's a pleasure to be here. One of the things that I want to start off just kind of thanking David for his remarks, but he's correct. What does any of this mean for you? And what it means is that you now know, if you didn't before, you live in an area that it's not a matter of if, but when it happens. And a lot of the, already in the Office of Emergency Management, we already look at Japan as our case studies for best practices, not just how to respond to and recover from, but preparing the community. The before, the things we do today on what we consider the blue sky, to better prepare our residents, anyone who lives in Seattle, works in Seattle, or comes to play in Seattle. A little bit about me, just why I do what I do is, first and foremost, I'm a survivor. So before I even knew that emergency management was a profession that I could dedicate my life to, I survived tornadoes in Texas. I've survived earthquakes in Hawaii, hurricanes in Georgia and Louisiana, and I'm from Eastern Washington, so I know winter weather more than just about maybe 90% of the people who were born and raised in Seattle. I'm here because I love the state of Washington, and I love working in the areas where I think that there are majority of the population would be most impacted, underserved, limited English speaking, and this is kind of why I do what I do. A little bit about some of the work that we do in the Office of Emergency Management. When you think about what is it that I have to prepare for, that's actually the first step. Like, what does your plan look like? What are you planning for? So we've already done a lot of the legwork in our office. We have a Seattle Hazard Identification and Vulnerability Analysis, which is a 300 and some page document that goes into every single one of the hazards you see on the screen in further detail. So these that you see up here, we've identified these as hazards that will impact or have impacted the city of Seattle in some way. One thing that you might notice is a lot of these hazards are actually connected to each other. And so for us in Seattle, what's a big takeaway that I just really want to make sure you walk away from is understanding that our worst case scenario is an earthquake on the Seattle Fault. So you've heard a lot about the science, you've heard a lot about the history. There are multiple faults in the state of Washington. The Cascadia Subduction Zone, which is off the coast along the Pacific Ocean, is a 700-mile-long fault zone. That will manifest a very significant earthquake. Fortunately for us, it is far away. That's not to say we won't feel the shaking. We're looking at 4.5 to 5 minutes of shaking when an earthquake happens on that fault. Why I say the Seattle Fault is our worst case is because that one is right under our feet. When that earthquake happens, recent studies suggest that we will experience a tsunami. And so now our worst case scenario has just expanded immensely, knowing that if it's 3.5 minutes of shaking, that's an earthquake on the Seattle Fault. we have a tsunami warning immediately. If it's for more than 3.5 minutes to possibly 5 minutes of shaking, that's a hint for you that it might not have been an earthquake on the Seattle Fault and instead might be the Cascadia Rising Zone. First and foremost, regardless of anything, when you leave here tonight, you should make sure to download the Washington Shake Alert app. It's an app that exists that allows you the opportunity to get advanced notification, even if it's just a small amount, 15 seconds, 30 seconds. You'd be surprised how much you can do in a little bit of time when it comes to just securing yourself, securing your loved ones, or securing your home. And so the number one is earthquakes. They don't happen that often. They actually do. They happen all the time, but you don't feel it, right? It's normal geological processes of Earth. They're always happening. It's normal. The Earth moves, and I like to call it the Earth is just breathing, ebb and flow. When we think about what does that mean for you, for community members, whether you visit here, you live here, this region is our home. And so we've identified that, I've been doing this for about 10 years now, and I feel like we always recreate the wheel, or we try to take something and change it new. But ultimately, in the last 5 or 10 years or so, we see this shift more towards needing to give community actual hands-on skills trainings. It's one thing for me to go to a room of an audience of people to say, oh, these are your hazards, these are things that you can do by good luck planning. No, we actually are in Seattle, we're taking this approach of a more direct, hands-on, these are your hazards, this is what you need to plan for, but let's take it a step further and look at where do you live in the city? What are your specific hazards? What skills do you need? Do you know how to use a fire extinguisher? Do you know where your evacuation routes are? I can keep going on and on, so I'm gonna try to be a little faster here. So ultimately, I haven't heard it yet, so I'm glad that I have a slide on this. When the ground starts to shake, you need to drop, cover, and hold on if you haven't done so already, or if you don't know that already. If there isn't a table around you, that's okay. The idea is that you're dropping to the ground, you're covering your vital organs, and you're holding on to the legs of a table if you can get under a table. In a setting like this, you would get in between the rows and stay down on the ground until the shaking stops. When you're outside, you stay outside, and if you're inside, you stay inside. During a tsunami, this is a little bit of a different, I kind of alluded a little bit already. The amount of time that the earthquake shakes can give you a hint or an idea on whether or not you could expect to see a tsunami immediately or over time. So stay on the ground once the shaking happens. If the shaking is more than 3 to 3.5 minutes, the tsunami epicenter is further, or the earthquake epicenter is further away. If the shaking stops at about 3 minutes, and I'm not expecting you to be watching the clock while the shaking is happening, it's just more kind of an estimation of time. Honestly, the earthquake I was in was maybe 30 seconds of shaking, and I thought that was minutes upon minutes upon minutes. And so normally I share a lot more of my stories, but for the purposes of tonight, and all my contact information is available. One other thing, just as David alluded, I'm your community engagement manager. As people who live or work or frequent the city of Seattle, I'm yours. But if you don't live in the city of Seattle and you live outside, but you travel to Seattle, I can help you find who your person is. And that's just a part of how we do what we do. We build relationships. We cannot do this alone. As I mentioned, we're here to create a culture of preparedness. That means preparing you folks, but it also means making sure I know the people I need to know today, as opposed to day 7 of a long-term event. When we think about the biggest thing about tsunami safety is staying informed. Today is the day to sign up for emergency notification alerts. Today is the day to go look and find the evacuation routes. New studies came out last year, and some of the changes that we've been making in our city here, not just off of recent data changes, recent events like the Noto earthquake, and every earthquake that happens, we study it to see how the community responds. But staying informed, signing up for emergency notifications, and looking at your evacuation route. So I can tell you in the next year or so, this year, probably by the end of the year, you'll start to see blue evacuation signs going up throughout the city. You'll start to see more coming through on media and social media, on outreach campaigns as we kick off our tsunami preparedness awareness. How many of you knew, and you probably already, this probably was timed perfectly, that we're at the beginning of Tsunami Awareness Week? So these are just some strategies to raise awareness. We actively work with local community organizations, faith-based organizations. We try to make sure that we're advertising in ethnic media. We have the abilities and programs that allow us to provide trainings in language to be able to hear this content in your native tongue. It makes the world of a difference for somebody who's just come here, who doesn't know the area. So these are just some resources that we are already actively utilizing to increase awareness in the city of all hazards, specifically tsunamis. We have tools available to you. This is just a couple of the tools that we manage out of the city of Seattle, but Washington State in general has an immaculate team that does outreach and education, and they actually host a larger website for the whole state to tap into called Basecamp. And that's where we share our resources. I don't need to recreate something because I can go into Basecamp and see that it already exists, and vice versa. So we have a couple of tools at your disposal here for the city of Seattle where you can plug in your direct address and find out the specific hazards you're at risk for where you live. This is just an example of one of our materials that we translate and circulate throughout the city. And then knowing your community, whether it's where you live or being a part of a group, studies show that communities have a higher success rate of recovery than individuals approaching this a major event. And so in Seattle, we have our emergency communication hub network. And this is a network that was built by and is managed by community members. So this is an interactive website you can go to find your nearest hub. This is just kind of showing some of the hands-on skills trainings that we offer the community here in the city of Seattle and is offered actually throughout the whole of King County. And then just some other ways to stay connected, whether it's through radio. We know in a worst case scenario, when there's no connectivity, no communication capabilities, we will be relying on our radios. Learn what a ham radio license is. Figure out how you can get your ham radio license and what uses it could be, how useful it could be following an event that impacts communication. Preparedness takes a village. Ultimately, it just comes down to prioritizing your relationships with people and looking at what is it that you need, who depends on you, and what would they need to make it through. And what are some relationships you can start to build, connecting with a community organization that maybe you already volunteer with. Ask them, do they know this information? Do they have emergency planning? Do they need support? You could even look at your respective educational institution, think, is there a youth community emergency response team on this campus? Is that something that maybe I can take charge and lead the effort? It was a lot faster than I intended, but hopefully I made it on time. And I guess we'll move right on into questions. Thank you so much for having me.
Okay, so next we have our Q&A session. If all the speakers can come up to the stage and take a seat. And we're gonna have microphones running around the room. Hirata-san, いらっしゃいますか?
Yes, I'm here. Can you hear me?
Any questions?
Yeah, I'm just wondering, if there are any easily accessible resources that we can get easily, like a website or something like that, or I don't know, tutorial videos. I know you mentioned some pretty essential skills, such as knowing how to use a fire extinguisher, things like that.
Yeah, actually on our main website at seattle.gov/emergency management, or you could just put emergency, it'll take you to our main website. We provide free classes, but on the website itself, we have our skills trainings in videos. So we teach you how to build an emergency toilet. We teach you how to use a fire extinguisher. And then we teach you how to purify water or how to turn off your hot water in your home on our videos. And those are actually also currently getting translated so that we have translated captioning for them, and then alert.seattle.gov is where you would go to sign on for emergency notifications. We actually have some advertisements circulating Como News right now for the rest of the month and into next month on promoting Alert Seattle.
Great, awesome, thank you.
Could you please explain the Seattle fault or the earthquake regarding the Seattle fault?
The question is how to explain the Seattle fault. as part of a train wreck is one of the metaphors that's used. And the idea is that Western North America is getting shoved around by these tectonic plates. And part of that is that the Sierra Nevada gets rotated up into the Oregon Coast Ranges, and the Oregon Coast Ranges get pushed north, and Vancouver Island sits there as a backstop. And the soft underbelly of Western Washington State is in there getting squeezed. So you end up with a bunch of east-west faults across Puget Sound. The satellite geodesy shows something like, I think, close to a centimeter a year of shortening between about Portland and Vancouver, North Vancouver, BC. And so that shortening is being taken up in the long term by the faults in between. And an earthquake like the one on the Seattle Fault 1,100 years ago takes up some of the slack that way. So that's thought to be the driving mechanism for those earthquakes. Hirata Sensei gave us for Noto Hanto, we also had a cause for compression, right? Which is somewhat different than the cause here, but still you need something to drive those faults. Is that the kind of explanation I should add one thing though on that, and this is in one of Sophia's slides, is that this worst case Seattle fault earthquake is something that doesn't happen very often. And that's been underscored by recent research in which benches on the floor of Puget Sound down at depths of 100 feet or more, those have been mapped, and their warping across the Seattle Fault has been compared with the warping of the marine terraces that formed 1,100 years ago. The benches down deep under the sound are thought to be about 10,000 years old. And they don't show more warping than is needed than the warping that happened 1,100 years ago. So the implication is that those underwater benches, they participated in that warping only, and that the only post-glacial, maybe past 15,000 years, the only post-glacial earthquake, really large earthquake on the Seattle Fault is the one that happened 1,100 years ago. So it makes, you don't even know what the repetition of such an earthquake is. We don't have a complete recurrence interval. We're living in one. We're maybe early in one, and then there was one that before that lasted at least 10,000 years, and we don't know how far back into glacial times or before it goes. So this is a really hard kind of earthquake to prepare for, because it happens so infrequently. I think it serves to make us a little bit humble before what the earth can do. And it provides, let's see, if you do something to support a school, to retrofit a school or a bridge for another kind of earthquake, it's probably not going to hurt when a big Seattle Fault earthquake happens. But on the other hand, the ground shaking from a magnitude 7.5 earthquake directly underfoot, as you could see with the Noto Hanto example, is really horrific.
If I can add to that for a visual, it's I-90. I-90 is built essentially directly on top of the Seattle Fault. So it's east to west flow. And then you can actually see, I've been told, I haven't had the pleasure myself, that at Alki Beach, there's a part where you can see the fault. You can see a piece of it come up. Help me out here, Brian.
If you're there in 1991 during an apartment building an apartment building excavation, you could see the marine terrace exposed in the cut. But I haven't seen that out there since. But the landform itself, when you look down to Alki from the ferry, you can imagine that as the eastern counterpart to Restoration Point.
I was wondering on what specific lessons Washington has been taking from Japan and how Japan's earthquake efforts have been affecting the efforts made for earthquake preparedness in Washington State.
So some of the biggest things that we look at when we look at Japan is we see how ingrained preparedness is at a very young age. It is remarkable. The culture of preparedness that exists in Japan is just such a beautiful thing. And so we're always looking at how we can integrate more with our schools. And it's easier said than done. In Japan, it's historically built into the structure of their family life, their school life, like everything. Little kids are doing CERT, which is Community Emergency Response Team training, which is a US thing that teaches you essentially how to be a responder in your own home, in your community. Little kids are doing this in Japan. And that's something that we've been looking at for a while. And our school system is so differently structured and a little rigid, K through 12, not above, not university levels. So they have so much information to teach in such a limited amount of time. For someone like me, who has been literally spending most of my career trying to infiltrate the school systems, we're making a lot of strides. So in Seattle specifically, we have started, we're always doing like guest lecture. We have, what we did in my office is we started a youth preparedness program. And we're looking at different ways through our youth preparedness coordinator to tap into already existing youth-centered programs, groups, organizations that exist. And then teachers tend to call us up when they need a guest speaker, which we take advantage of all the time. But really just trying to get these skills trainings, these hands-on life-saving skills trainings integrated more into school system type models that K through 12 is one of the biggest things I think is a lessons learned from looking at Japan and how they respond to and prepare for earthquakes. I'll stop there.
One thing I would like to see more of is, like American engineers adopting Japanese earthquake engineering techniques. And during one of my visits to Japan, it was, I can't remember now, 7 or 8 years after the big Tohoku earthquake, there was a group of structural engineers who were touring some of the buildings there. And so many of the buildings are built on these what's the word? Like they're on bumpers or rollers, so that casters kind of thing, so that when the ground shakes, there's some great videos online of this. You can see the building is just kind of moving back and forth like that, so it's not bending, so it's not damaged. In the earthquake, it's a technique called base isolation. And as far as I know, I only know of 2 buildings in Washington that are base isolated, your headquarters and your headquarters. Is that correct?
We're currently in Fire Station 10, so I'm not 100% on that one.
The new emergency management building
Then yeah,
downtown.
okay, so then
Yeah.
I just learned something new about my office. So that's very cool to know. I didn't know that.
Can I say, Japanese building code was modified, several times. The very important modification or improvement is in 1981. Okay, 1981. So in average in Japan, 80% of houses and buildings are earthquake resistant building in terms of this 81 building code. However, in average 80%. However, in Ishikawa, Noto area is only a half of houses or buildings are this building code. So that's the problem for us is in countryside, and also the ratio of elder person in countryside of elder person is now increasing. So the young people, the population of ratio of young people is decreasing. That's a very serious problem in Japan. So in the countryside, not all houses and buildings are earthquake-proof houses. This is a very serious situation in Japan. Okay, that's all.
We had an interesting situation in Seattle a couple of years ago, where the building code was upgraded specifically here and specifically for tall buildings, this was based on research done by folks at the U.S. Geological Survey and other places. They were looking at, Seattle sits on this big basin, and it's kind of like, some people liken it to a bowl of Jello. And so when you have particularly a Cascadia subduction zone earthquake, the shaking is kind of amplified in that bowl. And so these researchers did very, like simulation after simulation after simulation, and found that like in that kind of shaking, buildings of a certain height could whip back and forth more than the building code intended or, was designed for. And so the code was upgraded here and in Bellevue specifically for that. So that was a really great example of research being put into action.
Okay, I'm going to cut it off here, mainly because there is food waiting for us. So I will first of all say we thank all the speakers for their willingness to join us today. And again, we acknowledge the financial support of the Consulate-General of Japan. And lastly, we thank all of you for coming and for sticking with us this far. We have a raffle ticket. It's a $50 gift certificate to Melrose Grill, which is a Renton steak restaurant. And so, so I think most of you dropped the ticket in here. I think I'd rather hold it and have Kana draw.
I'm not sure if I'm going to pronounce this right, but Laura Perilla? Oh, congratulations.
Okay, so lastly, I just have a few housekeeping items. We have a survey, and if you could fill out the survey by QR code or on paper, it would help the Japan-American Society in planning future events. Speakers, if you could hang out together on stage here, we would like to take a group photo, which will help us with follow-up media coverage. And finally, we come to everyone's favorite part of a Japan-American Society gatherings, which are the networking sessions over snacks. So please join us in the foyer, which we have until 7:30. So that's 45 minutes from now. Thank you very much. Good night.